Thank you, Sonia. As Sonia said, I'm going to be talking about conversational AI. There's still a lot of challenges, and there's some solutions around. But I want to really ask, can these systems at the moment engage in natural conversation the way we do? If there's a bit of time, I'd like to talk about a couple of projects that I'm involved in currently. I think probably everybody's got something of these devices at home, and you've talked to them. Probably not really engaged in a proper conversation as yet, but that's something that's down the line. Now, these are actually some quotes from a paper by Kane Sims. The first one is telling us about the market. Every year, or every week actually, we usually get different figures coming out. I'm never really quite sure where these figures come from. The second one is about the technology aspects, the language models, and again, pretty regularly we have new ones. Palm is now a little bit outdated compared to some of the others. Amazon are actually producing a new one fairly soon, they've announced, which is going to be multilingual. And on that topic, we see that they're releasing multilingual voice applications, which relates to what we were hearing in the previous talk as well. Now, to actually engage in conversation from the point of view of a human being is not particularly difficult. Children do it from a very early age, from about 3 onwards. They can engage in more of a conversation than current AI systems are able to do. So it's actually seen very much as a challenge, one of the main hallmarks of AI itself. And it's actually a very challenging thing because we've attempted to do it in all sorts of different ways, and it's still one of the ongoing problems in artificial intelligence. So what actually is a conversation, and what's a conversational system? Well, the idea is that we can actually engage simply in a conversation, taking turns, making relevant responses and so on. And that is cast as being an easier and perhaps more intuitive way, if it works, than the usual sort of clicking on icons, drag and drop and so on. So let's have a look at what we can actually do in the current technology. One of the aspects that is particularly good at the moment is being able to ask questions and give commands. So things like this, really. And you can do that with your Google Home or your Amazon Alexa and various other devices. The thing is that in these, the user is controlling the dialogue, so it already comes from the user. So it depends very much if the user knows the sort of things that the application is going to be able to answer. And when you actually put the question, you have to be able to do it without any hesitations. You have to do it really as a fluent sort of input. Otherwise, the system is going to interrupt and say, sorry, I didn't quite get that. Can you please repeat, or something along those lines? From the technology point of view, it requires really extensive ability to recognize the speech of the user and then to actually understand that as well. Because in principle, the user can say anything. So that's a technology that has been developed fairly well. It's working pretty well. It doesn't always work, but if you persevere with it, it does work reasonably well. Now, in many cases, people actually want to ask a follow-up question. So you might have asked about Mo Salah, where he was born, and then you might say, well, how many goals has he scored this year, and something along those lines. This is just an example from an Amazon Alexa paper a couple of years ago. And you can see that when you're actually asking a question, then you might follow it up by saying there, where there refers back to San Francisco that you mentioned earlier. Now, This is actually done in Amazon by using a technique called contextual slot carryover. San Francisco is a slot within the original query, and the idea is that you're carrying over a reference to that slot in the next, potentially doing that in the next utterance. And so you need to have some way of actually tracking that. Now, within the actual Alexa implementation, there's a bit of a problem because San Francisco, in one case, is actually seen as being a weather location within a weather intent, and then later it's seen as being a city location, and later it's seen as being a navigational. And so actually keeping track of that is quite a challenging technical problem. Google also have a solution called rephrasing, where they rephrase the follow-up query. They use linguistic techniques along with machine learning to do that. So that's something that, again, is working fairly well within the current implementations. Now, another technology that has actually been around for a long time, if you remember the sort of telephone-based, that's landline telephone-based IVR type applications that have been around since the 1990s, where you get involved in some task, like booking a flight or a hotel or something like that, where once the system knows what you're wanting to do, it then asks you a series of questions to try and get the information that it can then use to look up something in the database and then give you the answer. So in this case, what we're doing is called slot filling. So an example, the user says book a flight, and we have a frame, which is a data structure in which several items are, in this case, unknown, and the task of the system is simply to ask questions to actually fill out the values for the slots in the frame. And the beauty of that is that if you actually have a query where half of the or some of the values are already filled, then it doesn't actually ask them. It actually just asks for the ones that are unknown. Okay. What is the current state of technology? Well, we have systems, and I'll just play this little dialogue here, which can actually engage in a multi-turn open domain conversation, as you can see. What they have to do in this case is to be able to handle arbitrary user input, like we had with the question answering. But they also have to be able to maintain context, because the questions or the turns that follow are related to the ones that went before, and they have to be able to maintain the context that relates to those, and by doing that, produce relevant responses. There have been different solutions to this. A handcrafted one, which has been very successful, is Steve Warwick's. It used to be called Mitsuku in Pandora Bots. It's now called Cookie. It's a handcrafted solution. He's been working on that for more than 15 years, so that's quite a challenge. And it's continually updated to take into account new facts and new situations. And it's actually performed very well in some competitions with some of the other more AI-oriented machine learning-based systems. Microsoft's ShowIce also can engage in multi-turn open domain conversations. There's the Alexa Prize social bots, which have produced, that's university teams which compete each year in a competition to produce a coherent conversation lasting up to 20 minutes. None of them have actually done that completely successfully. Last year, it was a team from the Czech Republic that actually was the winner. There's Facebook's BlenderBot, which is a text-based system. There are 3 versions of that now. I'll mention that a little bit later again. And this particular example is actually from Google's Lambda 2. Now, what do we need to make them actually more conversational? Well, or why would we actually need to do that? Well, in various areas of conversational commerce, it's going to be important to do more than just answering questions. You might want to have some sort of negotiation. If somebody's taken out an insurance policy, for example, they want to be able to discuss various pros and cons. The areas that I'm interested in, healthcare and mental health support and care for elderly people, are all areas where you want much more than just question answering. You want to engage in a conversation about particular issues. So what would we have to do to actually make them more conversational? Well as just simply being able to answer questions and deal with follow-up questions, there may be cases where things go wrong, and so the system needs, if the user doesn't understand something, that they want to ask a clarification question. They might want to correct something that the system has possibly misunderstood, or that they decide that they want to say something different. They might want to change the topic, request for help. Lots of different things that happen in everyday conversation that are much more difficult to implement within current technology. There's also the system then should be able to keep track of things. It should be able to, as well, initiate clarification if it doesn't understand what the user's getting at and what the user wants. Should be offer guidance, make suggestions, and generally repair and detect miscommunications. And this all involves as well the use of context, being able to keep contextual information, what was said previously in the dialogue, knowledge about the user as well, so that it says relevant things, and also knowledge possibly about the external environment, which might be relevant to the conversation that's ongoing. So the traditional approach, and this is still very well founded within industry, is to actually use best practice guidelines that have been developed over more than 3 decades now, where you actually determine the conversation as a predetermined graph. This is only a very simple example here. And that's designed as a conversational flow that the system will follow. Now, the benefit of that is that the designer can control the interaction totally, so you know exactly where things are going to go. But the trouble is that it becomes difficult to handle what are known as the unhappy paths, so where things may go wrong, where the user wants to do something different and so on. And you can try and build all these different unhappy paths into it, all these potential deviations, but it can very quickly get out of hand. This is an example from a few years back. There were actually 300 pages of these flow diagrams to sort of cater for all the different potential deviations. And you can see it's very difficult if you were wanting to unravel that and to look at any particular problems. It's really a minefield. The alternative is what's the current state in research, what's known as neural dialogue or end-to-end dialogue, where you have an input sequence and then that is mapped onto an output sequence. The input is encoded, it's vectorized, and as the processing continues to the end of the input, you have what's called a context or a thought vector, which represents the state of the input at that particular point. And then that's taken as something which is then fed to the decoder, which on a word-by-word basis then produces the output, which you can see then at the end. Now, that technology is very much the state of the art. It's been used very successfully in applications like quick replies and machine translation. So when you're actually writing things, quite often you find potential next sequences of what you could actually say or click on. And that has now been applied to open domain conversation. And the technology that's been used, I'll not really have time to go into that, is what's called the transformer architecture. However, there are certain problems with neural dialogue at the moment. First of all, they require large amounts of data and vast computing resources. So, for example, to train one of these models costs as much in energy as a trans-American flight. And it's getting more and more as these become bigger and bigger. So from that point of view, from the environmental point of view, and also from the point of view of smaller groups that are wanting to work on these things, it's actually totally out of reach. From the point of view of the performance, these systems quite often lack a long-term memory. So like an example might be where the user says, well, where do you live, to the chatbot? And the chatbot says, I live in London. And then later on, a similar question is asked about where the chatbot lives, and it says, I live in Madrid. And so it doesn't remember that originally it had said London. There are lots of ways that people are trying to address that by having a consistent persona that's then recorded and then used to actually keep track. But it's still one of the problems. Another is bland responses. So instead of saying anything really particularly interesting, the system just says, okay, that's right. And that's because these are more frequent in the data. Worse still is where the system produces offensive and potentially unsafe responses. So an example was where a user in a social application said, I'm feeling really desperate. Sorry? Yeah, I want to commit suicide, and the system says, go ahead. And there are cases of hallucination. This is just an example where, from the Facebook, where it's saying about Mark Zuckerberg and saying about he wears clothes that are really old-fashioned and so on. He has more money, he should be doing better than that. Some of the solutions to that are to Lambda has various metrics, including, for example, groundedness, where it will actually look up the internet. BlenderBot has similar solutions. Just very quickly, I'll mention the Open Voice Network, which is looking at interoperability, discoverability, privacy, and voice data security. And I don't think I'm really going to have time now to look at these, but you'll be able to see them on the slides and follow up the references. So takeaways, there's a lot of activity. The research is currently focused on deep learning methods, but probably people are going to have to look at hybrid methods, taking into account the more rule-based, handcrafted methods as well, which involve reasoning and representation. There's a lot of issues where people are looking at design and implementation, but we also need to look at co-creation and user involvement, which I think some of the other speakers will also be talking about. And some light reading. Steve Young's book is really interesting. It presents the technology from the point of view of the assistant itself and how it does things. Robert Piercini's book, and then also my book as well. So thank you.